Okay, so in this video I'm going to finish the lesson 1.1b. This is where I left off with most of the sections. The empty set symbol is this circle with a slash through it. Now, empty sets come up, you'll see them throughout the rest of this chapter. You might be wondering, why is there a symbol for an empty set? I'll just show you one of the times when the empty set comes up, and that might be like if you had the set defined A to be the even integers, let's say, and B was the set of odd integers. And I asked you to come up with a set C that was the overlap of A and B, meaning the set of numbers that A and B have in common. So you're thinking like, there is no number that is in both set A and set B. So if I asked you to write the set that they had in common, well, that set would be empty. So you could write it as this, which is an empty set of brackets with nothing in it. Or you could simply write that C is the null set. So you don't need to put the null set symbol inside of the brackets. That's kind of redundant. You can either draw empty brackets or save yourself the effort and just write a 0 with a slash through it, or a circle with a slash through it. Concept that's worth knowing is that the empty set is a subset of every set. So if I had the set A defined as P and Q, lowercase p, lowercase q. I'm not even putting numbers in here. And then I said, list me all the subsets of that. One of the subsets would be just p. One of the subsets would be just q. One of the subsets would be the identical set p and q. And one of the subsets would be the null set. And actually, we don't need to put the brackets around that like I just said on the previous slide. Just the null set symbol on its own is a set. So the empty set is considered a subset of everything. And then, of course, the second note here says that every set is a subset of itself. But we should understand that from our discussion of and definition of subsets, right? Every set is a subset of itself. And then we're going to get into the new bit here. So this is a picture of a Venn diagram where we have set A in one circle and set B in the other. And we don't need to know what they are. In the note on top, it says M and N, but the same thing applies to A and B, right? What we're defining here is the region in yellow on the picture. It's called the intersection. So when I talk about the overlap region, the math vocabulary word for that is the intersection. So the intersection of set M and N or set A and B is the set of all elements that are in both. And the symbol for it is down here at the bottom of this slide. So make sure you get that symbol in your notes. That when you see A with this sort of upside down U shape, B, that means the intersection of A and B. The intersection of A and B. That's how you would read it. Intersection of set A and set B. All right. So that's one word worth defining in your notes. The next word would be the union of set A and B, or the union of set M and N. And union, as you can see shaded on the picture, is the entire region A and the entire region B and the overlap region all shaded together. So this one, though it seems easier, is actually the one that puzzles people more when you see it in application. You'll be surprised, but it'll happen to you too. So the union of A and B, I like to think of this as like the word union is sometimes used for a marriage, right? It's the union of two people. Well, the spouse A brings all of their stuff, and the spouse B brings all of their stuff, and now they are living in union, right? They have to find a way to make all their stuff work together. So it's not like they're just keeping the parts of themselves that overlap, right? They're bringing each their own individual things and personalities and the parts that overlap as well. So a union just brings it all to the table. And of course, only we're talking about A and B. We're not talking about the stuff outside of A and B. So the union involves everything in A and everything in B, whereas the intersection only involves the stuff they have in common. The definition of the word disjoint would be sets that have no elements in common. So that would be like on a Venn diagram. Two circles that don't overlap, or circles that overlap but don't have anything in the overlap region, so could be drawn separately. We would say that those are disjoint sets, like the even and odd integers. And then these are some practice examples. I'm not going to go through them all here. If we had time in class to do this, we might have gone over some examples. I will just go over let's say part A, maybe just question A, so you can see the practice here. Question A asks you to write down the set A intersection D. I know that's the intersection because it's the symbol, the upside down U, right? A intersection D. They're asking you to write it down as a set. So A is its own set, D is its own set. The intersection of A and D is a different set where you're just listing the things that are in the intersection, in the overlap region, the things they have in common. So if you look at A and D, which are defined up above, you will see that the only numbers they have in common, the only elements they have in common are 4 and 5. So that's how I'd want you to write the intersection set for A and D. I'm not going to go through all the other examples here. And this would be practicing some unions. Again, we can just do part A, example A, which asks us to write down the union of A and D. So the union of A and D, also write it as its own set. You're looking at A bringing all of its baggage to the table, and D is also going to bring all of its stuff. And we're not looking for overlaps. We're just going to list it all. It's a mega set that includes A and D. So it's got 1, 2, 3, 4, and 5 in it from A. And then D is also bringing 4 and 5. We don't need to rewrite them. But then we would also add 6 and 7 to the list because D has brought 6 and 7. So the intersection, or the rather union, would involve 1, 2, 3, 4, 5, 6, and 7. Okay, and that's the end of the notes. That should give you enough to get started on your homework.